Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be looking at another example still under the quotient rule method of differentiation. So the example as written on the board says that y is equal to 12x squared, 12x plus 1 raised to power 4 divided by 2x squared plus 5 raised to power 3. So looking at this, we can see we have two terms dividing each other, and this still falls under the quotient rule method of differentiation. And if you observe this very well, you can see they have a power. And what this is telling us is just that there is a tweak in this kind of question. And what are we going to do in this kind of question? You can see this is looking like a chain rule method of differentiation because it is carrying a power. So how do we solve this question? Using the quotient rule method of differentiation. So in doing this, we say let our u to be equal to, so we have u is equal to 12x plus 1 raised to power 4. So we are going to get the u with respect to what? To x. So differentiation of u with respect to x, which is given as what? Du over dx to be equal to. So in order to differentiate this, we are going to use what? The chain rule shortcut method of differentiation. So if you did not know the chain rule shortcut method of differentiation, I'm going to drop a link under the description of this video. You can check where we solve or where we discuss the chain rule shortcut method of differentiation under the description of this video using the link provided. So in doing that, we say, so in using the shortcut rule method of chain rule, we say the power will come to the front. So we are going to have 4 multiplied by, so we can represent the multiplication as dots. So we are going to differentiate everything in this bracket. So when you differentiate 12x plus 1, this is a constant, the 1 is a constant, it's going to give us 0. So we are going to be left with 12x. So when you differentiate 12x, you are going to get 12. So we have 12. So we have dots. So we are going to rewrite the bracket. So we have 12x plus 1. And also the power will be subtracted by 1. So we have 4 minus 1. So this is just how to differentiate using the chain rule shortcut method of differentiation. So the power will come to the front, you differentiate what is in the bracket, you multiply it with the power, and also you write the bracket again, you multiply it with what you have on ground, and the power will be subtracted by 1. So when you solve this, we are going to have, so 4 multiplied by 12 will give us what? We are going to have 48, open bracket, 12x plus 1 raised to power 3. So this is what we are going to get when we differentiate this u. So the next step is to let v. So we have let v to be equal to, so our v, which is the denominator, we have 2x squared plus 5 raised to power 3. So we can get the differentiation of v with respect to x, so which is given as the v over dx to be equal to. So we can see this is also a chain rule method of differentiation, and we can use the chain rule shortcut method. So in using the chain rule shortcut method, the power will come to the front. So we have 3 multiplied by, so we differentiate everything in this bracket. So when you differentiate 2x squared plus 5, this 5 is a constant, it will give 0. So we are going to be left with what? 2x squared. And when you differentiate 2x squared, you are going to get what? We are going to get, the power will come to the front, we are going to get 4x. So we have 4x multiplied by, so we are going to write the bracket, which is what? 2x squared plus 5, and the power will be subtracted by 1. So we are going to have 3 minus 1. So in doing this, we are going to get, so 3 multiplied by 4x will give us what? 12x, open bracket, 2x squared plus 5, close bracket, 2. So this is what we are going to get when we differentiate v with respect to x. So now that we have gotten our parameters, we can then proceed to use the formula for the quotient rule method of differentiation, which is given as dy over dx to be equal to v du over dx minus u dv over dx all over v square. So this is our quotient rule formula for method of differentiation. So in solving this further, we know that our v, what is our v? Our v from the question is what? 2x squared plus 5 raised to power 3. So we have, open bracket, 2x squared plus 5 raised to power 3 multiplied by, What is our du over dx? Our du over dx is what? 48 open bracket 12x plus 1 raised to power 3. So we can put that in a square bracket. So we have 48 open bracket 12x. So we have 12x plus 1 raised to power 3 minus. So this is the minus. So what is our u? Our u in this case is what? So our u is 12x plus 1 raised to power 4. So we have 12x plus 1 raised to power 4. So multiply by what? So what is our dv over dx? Our dv over dx is given as what? 12x open bracket 2x squared plus 5 raised to power. So we can just manage to write that here. So we have 12x open bracket. So we have 2x squared plus 5. So 2x squared plus 5. Sorry about that. Raised to power 2. So just be following. So you get it. So now that we have gotten this, all over v squared. Don't forget our v squared. So all over, what is our v square? Our v square is what? So we have our v. Our v is 2x squared plus 5. So we have our v 2x squared plus 5 raised to power 3. So we square bracket it because of the square. So this is our v square. So this is our v and this is the square. So now that we have done this, we can then rewrite this numerator. You can see that everything here is a single term and everything here is also another distinct term. So what is bonding this together is a multiplication, and also what is bonding this together is also a multiplication. The difference is just that they are separated by what? A subtraction sign. So in doing this, we can rewrite this. Multiplication is commutative in the sense that if you have something like 6 multiplied by 3, this is going to give us what? 18. And you can also rewrite this as 3 multiplied by 6, which is also giving 18. So the meaning of commutative is just that you can arrange it in different positions and you are still going to get the same answer. So we can apply this to what we have as the numerator by rewriting these terms. So you can see we have 48 open bracket 12x plus 1 here. So we can bring that out. So we can have 48 open bracket 12x plus 1 raised to power 3. So we can also rewrite this as dot open bracket 2x squared plus 5 raised to power 3 minus. Also we can do the same for this by bringing this 12x to the front. So we have 12x open bracket 2x squared plus 5 raised to power 2 minus open bracket 12x plus 1 raised to power 4. So we can rewrite this in this sense all over. Don't forget our v square. So from the law of indices, this can multiply this to give us 6. So we have 2x squared plus 5 raised to power 6. Because when you multiply 3 multiplied by 2, you are going to get 6. So this is what you are going to get for our numerator. So in moving further, you can see this is a single term and this is another single term. So this is addition. So this is dot. So this is multiplication rather. So it is represented as dot. So we can see we have a single term and also we have another single term. So what is separating them is what? Is this minus. So in this case, we can then factorize this numerator. And in order to factorize, you have to look for the terms that can divide these two together. So from what you can see here, we can see 48 and we can see 12. So what can divide 48 and 12? So this is a term and this is another term. So this is just the subtraction sign that is separating both terms. So what can divide 48 and can also divide 12? So we know that 12 can divide 48 and 12 can also divide 12. But 48 is not having x and this is having x. So we just ignore it or limit it to 12. So we have 12. So let's also look at this bracket. You can see we have 12x plus 1. Also look at the second term. You can see we have 12x plus 1, but this is raised to power 4 and this is raised to power 3. So all we just have to do is to bring the one with the lowest term. So in this case, we have open bracket 12x plus 1 raised to power 3 because that is the one with the lowest term. Also multiply by. So which term can we also see? We can see 2x squared plus 5 raised to power 3 and also we can see 2x squared plus 5 raised to power 2. So in this case, we are going to work with the one with the lowest term. And the one with the lowest term is what? 2x squared plus 5 raised to power 2. So that is the one with the lowest power. So we are going to bring 2x squared plus 5 raised to power 2. So this will be our factorization. So now we can now use this to divide both terms. So 12 in 48 will give us what? We are going to have 4. So 12x plus 1 raised to power 3 divided by this. So it is going to cancel out this. So we are going to be left with 1. So 4 times 1 will give us what? 1. Will give us 4. So this is going to cancel this. So this will cancel this. So the next, which is 2x squared plus 5. So 2x squared plus 5 in this 2x squared raised to power. In this 2x squared plus 5 raised to power 3. So we can see this is raised to power 2 and this is raised to power 3. So this is just going to cancel 2 out of this. So we'll just be left with what? 2x squared plus 5. So we have 2x squared plus 5. So this is what we get when we divide everything here by this first term. So moving to the second term, we have minus. So 12 divided by 12x. So we are going to get what? So this 12 will cancel 12. We are going to be left with what? X alone. We are going to have x. So now 12x plus 1 raised to power 3 divided by 12x plus 1 raised to power 4. So this 3 will cancel 3 out of this 4. We are going to be left with 1 12x plus 1. So we are just going to have open bracket 12x plus 1 close bracket. So the next, which is 2x squared plus 5 raised to power 2 divided by this 2x squared plus 5 raised to power 2. So this is going to cancel everything out here. So we are going to be left with nothing. So we are going to have this as our factorization. So all divided by our v square, which is what? 2x squared plus 5 raised to power 6. So this is going to be given as our final answer to question of this type. You can see it is very, very simple. You just have to put your mind when you are factorizing. So the first step is to look at what can divide this term and this term. So you can see we have 48 and 12. So what can divide 48 and 12? So 12 can divide 48 and 12. But looking at this 48, it does not have x the way 12 have x. So you are just going to limit it to 12. So looking at the next bracket, you can see 12x plus 1 raised to power 3. Also looking at this second term, you can see 12x plus 1 raised to power 4. So we are going to remove the one with the lowest power. So in doing that, we are going to remove this 12x plus 1 raised to power 3, which is what we are going to have here. Multiply by the next bracket, which is 2x plus 2x squared plus 5 raised to power 3. And also looking at this, we have 2x squared plus 5 raised to power 2. So also we are going to remove the one with the what? The lowest power. So in removing the one with the lowest power, we are going to be left with what? 2x squared plus 5 raised to power 2. And that is what we have here. So you can now factorize this by putting a square bracket. And in factorizing, we have that 12 divided by 48, we are going to have 4. Also, looking at the next term, which is 12x plus 1 raised to power 3. So 12x plus 1 raised to power 3 divided by everything here, this is going to cancel out this 12x plus 1 raised to power 3. And that is why we are left with nothing. So the next one, which is 2x squared plus 5 raised to power 2. So 2x squared plus 5 raised to power 2 divided by 2x squared plus 5 raised to power 3. So this 2 is going to cancel 2 out of this 3. So we are going to be left with 1 2x squared plus 5. And that is what we have here. So the minus, which is what is separating the two terms. So looking at this, we have 12 and we have 12x. So 12x divided by 12, we are going to be left with what? X, because 12 will cancel 12 and x is what we are going to be left with. So the next one, which is 12x plus 1 raised to power 3. So 12x plus 1 raised to power 3 divided by 12x plus 1 raised to power 4. So this is 3 and this is 4. So this 3 will cancel 3 out of this 4 and we are going to be left with 1 12x plus 1 and that is what we have here. So the last one, which is 2x squared plus 5 raised to power 2. So 2x squared plus 5 raised to power 2 divided by 2x squared plus 5 raised to power 2. So this is going to cancel out this. So we are going to be left with nothing. And that is how we have our factorization. And we are going to put our v squared, which is 2x squared plus 5 raised to power 6. And this is our final answer to question of this type.